welcome to T Academy. In this video I will discuss the previous APTRANSCO Assistant Engineer Electrical paper 2019 solutions, and in this session I am going to discuss the networks as well as the utilization of electrical energy. So let's start here. The first question is, in a steady state, what will be the capacitor C2 voltage if C1 is equal to C2 in the circuit given below? So here they given a voltage source and a capacitor C1, C2, and there is a resistor R here. They are asking that what will be the voltage across the capacitor C2 if the values of C1 and C2 both are equal. Okay. So the options they given as a V by 2, P and C is 0 and D is V by RC here. Okay. So I'll show the solution of this problem here. I will explain here. See. So here there are two capacitors. So C1 and C2. Here we should remember that during the steady state condition, the capacitor act as a open circuited. So open circuited, that's the reason why here the VC1 and VC2 are considered. So remember this point, at steady state condition the capacitor act as a open circuit condition here. Okay, so just it's a simple voltage division rule here. Okay, voltage division, what it says that the voltage at X point is equal to the total voltage. In case of resistors, we will take the particular value of the resistor where you want the voltage, but in case of capacitor it's opposite. So here you want to find the VC2, so here C1 divided by total capacitance C1 plus C2. Okay, so like that we'll write here. Okay, C2 here. So now I have taken the same formula here, and after applying that C1 value equal to C2, then answer will be VC is equal to V by 2. So that is the answer for this question here. We'll move to the next question here. Right. The question here it is, what will be the shape of the current in the circuit? So in this circuit there is an voltage source of DC and there is a AC voltage source which are connected to the inductor here. Okay. So here you have to do derivation of V is equal to L into dA by dt DC circuit. Okay, sorry. So here we have to apply the superposition theorem. Okay, SPT. So by considering only one source at a time. Okay, first we will take the DC source, next we will take AC source, and you have to find the response, and finally the response of this circuit will be D. Okay, so D will be the correct response for this problem here, solution here. Okay, so next, so answer is the shape of the current in the circuit is like this. Okay, next question here it is, if the voltage across the resistor is equal to supply voltage, then what will be the ratio of voltages between L and C? So by looking the network itself, here is a AC source, inductor, capacitor, resistor, as you see in here. Okay, so these three elements are connected in series, and the question is asking it, what is the voltage across the resistor? The voltage across the resistor is equal to supply voltage, then Vs is equal to VR, then what is this components L and C are doing? So they are cancelling each other, and this condition is known as resonance condition, as you know. Okay, so the circuit is under resonance condition. Okay, so the answer will be here. What is the answer? So during the resonance condition, as you know that the voltage across the inductor is equal to the voltage across the capacitor, the magnitude. In the given question they are asking to find ratio of voltage, yes, absolute between L and C. Absolute means a mod value. Okay, so the voltage across the inductor and capacitor are equal. The ratio of the voltage between the L and C is equal to be 1. So that is the reason why the answer is for this question is A is the correct answer. So let's move to the next question here. Okay, so there's a technical glitch here. So what will be the, so okay, I will change this, right? So we'll change the next question here. The problem is there, right? Okay, next question here. Okay, next question. If R1 is equal to R2, what should be the voltage magnitude to have a zero current through R3? The network is given like this. Here, if the current in this element R3 is 0 and R1 value equal to R2, then what will be the voltage of V so that the current in the R3 is 0? So simply here there is a shortcut here. So R1 is equal to R2, that means this resistor and these resistors are equal, and this magnitude and this magnitude should be opposite in polarity. At the time the R3 current flowing is 0. So this is a shortcut. Okay, and if you want to derivative analysis, then we'll see the problem here. Okay, so solution here. So okay, so let's continue the discussion here. There is a small glitch here. Okay, so here the network we have considered. I'll zoom it. Okay, right. So to do the solution here, first what we will do is we will take this voltage as Vx and 5 volts here, V here, R1, R2, R3. So by applying the nodal analysis here, so Vx minus 5 divided by R1 plus Vx divided by R3 plus Vx minus V divided by R2 equals 0. So that's what I have written here. And further simplifying that equations here, so you will see here. So by simplifying this and taking the current through the R3, that is a resistor R3 is carrying a 0 current. So how can I write here? It is nothing but, so current in the R3 is equal to the voltage across the R3 is Vx divided by current, here it is IR3. Okay, so IR3 is 0, that means Vx by R3 here, like this. So by simplifying this again here, simplifying this, you will get the answer as Vx is nothing but minus 5 volts here. Okay, so previously I skipped one question here, so I will try to give the solution for that also. Alright, so this is the question here. Okay, in the given question, what will be the voltage, what will be the average power drawn for the voltage source? So what is the average power drawn for the voltage source? So here we have an voltage source and there is a current source and resistor here. So average power drawn for an inductor and a capacitor. For example, the average power drawn for inductor comma capacitor is going to be 0. But here they are specifying a resistor here. So average power drawn by resistor is not equal to 0. Okay, that means, so you will choose that option B is, you can eliminate the option B. But observe here, the tricky question here itself, they given Vm sin omega t in a series with a current source here. So there is a current source here. Okay, so what the current source will do is, when you are following the superposition principle, I will explain here. So by applying superposition theorem, first we will eliminate one source. So the eliminate current source here and using only voltage source. Why? Because the area of interest in the question is voltage source. When you are considering like that, the Vm sin omega t is like this. The current source is going to be open circuited here like this. So once the open circuited, the current will not flow through this resistor. Okay, so what is the power drawn? So power drawn will be automatically 0 here. Okay, that is the explanation in this presentation here. Okay, so this question we solved already. Okay, and next we will see the question here, right? This one. So what will be the rise in capacitor voltage per second? So what will be the rise in capacitor voltage? So 5 volt source is here, 2 amps current flowing here, and there is a one capacitor here. So first of all, understand the behavior of the capacitor. In the first question we discussed that when the capacitor is in a steady state condition, it acts as a open circuit here, open circuit. But see here, raise in capacitor voltage. So that we need to calculate here. So let's find the solution for this question here, right? So assuming that the initial conditions, that the capacitor is initially a uncharged one. So as the initial voltage across the capacitor is 0, Vc of 0 is equal to Vc of 0 plus instantaneous values of 0 is going to be 0 here. So when the capacitor voltage is 0, here it's a short circuited. Okay, here it is a short circuited here. Okay, initial condition. And current through the capacitor IC is equal to I is equal to C into dVc by dt. I is nothing but what is that? Current will 2 amps will flow continuously like this. It's short circuited now, so current will be 2 amps flow here. So IC is equal to 2 and the C value is 2 microfarads. So 2 dVc by dt is nothing but dVc is equal to dVc by dt is equal to 1 volts per second. Actually there is some correction is there. So we'll do one thing here. So consider this 2 volts microfarad as a 2 farads. Then the answer will be 1 volt per second here. So thus the capacitor voltage will be 1 volt per second. So actually here it should be microseconds should be there. So okay. So understand the concept here. Okay. Next question here. At a particular unbalanced load node, the real powers is specified as leaving the node is a 20 megawatts, 25 megawatts. So leaving is 25, entering is a 60, 30. So entering is 60 plus 30, 90 megawatts. So what is the balancing power? Okay, 30 megawatts leaving the node, 45 megawatts leaving the node, 45 megawatts entering the node, 22.5 entering the node and 22 megawatts leaving the node. So we can eliminate the option D here. Why? Because 45 is leaving, 90 is entering. So what about the remaining 45? Okay, so answer I will show you here. So see here. So 60 megawatts and 30 megawatts combined together entering at 90 megawatts. So 20 plus 25. So 45 megawatts are leaving. Okay. So the balance power 45 megawatts should have how much? 45 megawatts leaving the node. So leaving the node. Okay. So 90 is coming, 45 is there. So there should be another node. So which will have 45 megawatts. Okay. So 45 megawatts. So the answer will be, thus the balancing power will be 45 megawatts leaving the node here. So next question here. A series RL circuit excited at t is equal to 0 by closing the switch as shown in the figure, assuming 0 initial conditions, the value of d square I by dt square at t is equal to 0 plus. A series RL circuit is shown here. A DC source is here, switch is here, and the current is flowing I, and R is a resistor, L is an inductor here. So what will be the d square I by dt square? So this is a direct question. So in your examination, if you are deriving, it will take a lot of time. So the answer will be d is equal to d is minus r by l square into v, or we can say minus rv by l square, like that. So let's see the derivation part for this question here. Initially, assuming that t is equal to 0 plus, the inductor will be uncharged. Okay, I is equal to d I of 0 plus is equal to 0. Uncharged means inductor is open circuited. Okay, so KVL into the equation here, v is equal to r into di by dt, and substituting at t equal to 0 plus, v is equal to r into I of 0 plus plus L into d of 0 plus with dt. Okay. Next, here di of 0 plus by dt is equal to v by L. So why? Because sir, I of 0 plus is 0 value. Okay. Now differentiating this same equation again, this equation here, again dvL by dt like this. So answer will be this one. So d square by dt square is equal to minus r into v divided by L square is the answer for this question here. Okay, next question here. Okay. So if you observe the previous AP Transco paper here, one thing you can ensure that the lot of questions are coming from the transients networks, transients. Okay, see here, determine the circuit current through the capacitor during steady state condition. So already you know the first question that studied that the capacitor under steady state condition act as a open circuited. So when there is a open circuit, what is the current? So current will be 0 amps. So that is the answer for this question here. Okay, so the explanation like this here. Okay, at steady state condition the capacitor act as a open circuit, the current will be 0 here. Okay, so next question here, two port network. In a linear two port network, when the 10 volts is applied to port 1, a current of 4 amps flowing through the port 2 when it is short circuited. When the 5 volts is applied to port 1, a current of 1.25 amps flowing through the 1 ohm resistance connected across the port 2. When 3 volts is applied to the port 1, the current through the 2 ohm resistor is connected to port 2. So there are three conditions are given. The first condition is at a port 1, apply 10 volts, 4 amps current flowing, short circuit. Second case, when 5 volts applied at port 1, 1.25 is current flowing and the load resistance is 1 ohm. Third case, 3 volts applied, port 1, 2 ohm resistance at the load, and what will be the current here. Okay, so let's discuss a solution for this here. So see here, so it's a derivative part little bit. See, observe here the conditions we considered. So V1 is 10 volts, I2 is equal to 4 amps, short circuit means V2 is 0. Second case, V1 is 5 volts, I2 1.25 amps, and V2 is V is equal to I into R, 1.25 ohms, 1.25 amps into resistance of 1 ohm is 1.25 volts. V3 is, V1 is 3 volts, I2 is how much? At R is equal to 2. And we know the basic condition for the two port network here. So this is the important formula here that you should keep in mind. Okay. So from the conditions 1 and 2 substitute here. So we'll get the derivation. A is as 1.5, and similarly conditions above substitute the values here. You will get the I2 as a 0.54. So that the answer for this question is A, and I value is 0.54 amps here. So answer is 0.54. C is the right answer for this question here. And this question is from the utilization of electrical energy. Okay, so let me tag here. So UEE question here. The scheduled speed of a train over a level track is 30 kilometers per hour. Scheduled speed is 30 kilometers per hour. The distance between the stations or stops, we can say 1 kilometer, and the station stopping time is 20 seconds. The average speed of the train is. Okay. Let's discuss solution here. So we know that the speed is nothing but distance by time. So this is formula, you know. What is the distance between the each stop? 1 kilometer. The total time, how much they are traveling, we need to calculate, and the scheduled speed of the train is 30 kilometers per hour. So from this, total time is equal to, okay, speed divided by 30. So speed is about 1 kilometer per hour, okay, and time is so 1 by 30 kilometer gets cancelled, 1 by 30th of an hour. So 1 by 30th means if you take in seconds, 3600. So I will write here 3600 seconds divided by 30. So once you are doing this, you will get 120 seconds here. So 120 seconds here, and for each and every station the stopping time is how much? 20 seconds. So time in which the train is traveling, why? Because stopping time is 20 seconds. Okay, so the time of the track or the time of the train traveling is from 120 seconds to 20 seconds decreasing means 100 seconds. It's only traveling. So 20 seconds is stopping time. Then what is the average speed? Average speed is equal to distance divided by time during only running condition. So 1 kilometer divided by 100 is nothing but 36 kilometers per hour. So okay, so observe here the scheduled speed is lesser than the average speed. Understand the concept here? So let's move to the next question here. Okay, see here, so this is from the resonance condition. So focus on the resonance condition as well as the transients if you are preparing for a Transco exam. Okay, the value of Z in the figure, which is the most appropriate cause parallel resonance at 500 Hz. So parallel resonance, in these previous discussions we discussed about a series resonance. Okay, now we are discussing about parallel resonance. So here we have a voltage source, they didn't mention any value here. Understand the concept. 5 ohm resistor, 2 Hz inductor and Z value. So what will be the appropriate value here? Okay, we know that inductor is there means automatically capacitor will be there. So what is the value here at frequency of 500 Hz? Let's discuss the solution here. So resonance will occur only inductor is in capacitive parallel. So inductor is in parallel with the capacitance, and the total acceptance of the circuit will be equal to 0. Okay, so here we consider this 1 by j omega L plus j omega C is equal to 0. So from this derivation, it's a simple derivation only, there is no need to do any derivation. If you remember this formula here, omega equal to 1 by square root of LC. Substitute the value here, you will get the answer as C is equal to 0.05 microfarads. So answer for this question will be D, 0.05 microfarads. Okay, next question here. Next question, a high Q, that means high quality, or high Q factor, high Q quartz crystal exhibits series resonance at a frequency Ws and a parallel resonance at frequency Wp, then the conditions are given here. Okay, so this is a previous gate question, so gate EC branch question here. Okay, let's find the solution for this here. So I'll directly show you the options here. So see here we have a RLC circuit, and Cs is the capacitance of the series circuit and Cp is the capacitance of the parallel circuit here. So here you should understand the behavior of the circuit here. So this is the important graph here. Okay, so in this graph we have a frequency in x-axis and output impedance at y-axis. See here how the circuit behaves is, first it's a capacitive in nature up to this point, after that it's inductive in nature and capacitive in nature. So inductive in nature is only at the crystal frequency. So we'll minimize this. So crystal frequency here, crystal frequency, and in the question they are asking Ws and Wp how they are related. So Ws and Wp are very close to each other, very near to each other, but Wp is greater than Ws here. So that is the conclusion here, and you can see the formulas and everything will be here in the presentation here. So Ws is very close to but less than Wp in quartz. In quartz crystal frequency of oscillation chosen between Wp and Ws here. So the answer for this question is D. Ws is very close but lesser than the Wp here. Okay. Okay, so let's move to the next question here. Okay, next. So this question is from the utilization of electrical energy, right? The relation among the specific energy consumption is the total energy consumption in watt hours, the train weight in tons, and the distance traveled is d in kilometers is. So this is a direct question that they are asked from the utilization of electrical energy. I will show the answer here. So answer is nothing but D here. The energy consumption is equal to the energy consumed in a train in watt hours. Sometimes they are asking also units also, watt hours, and the weight of the train in tons. Okay, and the distance of run in kilometers. The units is watt hour per ton into kilometers. Okay, so energy consumption is equal to energy consumed in the train in watt hours divided by weight of the train in tons into distance of run in kilometers. Okay, so that's it friends in this session. We'll continue the next session of APTRANSCO 2019 AE solutions. Thank you. Have a nice day.